Hi, this is Sir Absalon of MathAlas channel, and welcome once again in another episode of Learning in Mathematics.
Let us first recall the definition of a zero of a function. Suppose that we have a function, not necessarily a polynomial function, and r is a real number for which f of r is equal to 0. Then we say that r is a real zero of f. Suppose that p is a polynomial function, then the following conditions are equivalent. R is a real zero of p. R is an x-intercept of p. X minus r is a factor of p. And r is a solution to the equation p of x is equal to 0. Basically, this is just saying that zeros and x-intercept are basically the same. And if we already know a zero of f, then we already know one factor of p. Because if r is a real zero, it automatically means that x minus r is a factor of p. Now suppose that x minus r raised to m is a factor of a polynomial p, and if you increase the exponent by 1, it is no longer a factor of p. Then we say that r is a zero of multiplicity m of p. Suppose that p of x can be written as the square of x minus 2 times the cube of x plus 1. From the previous slides, we know that the zeros of p are 2 with multiplicity 2, because this is the exponent, and negative 1 is a zero also with multiplicity equal to 3. The multiplicity of the zeros are just the exponents appearing in the factorization. What does this multiplicities tell us? The multiplicities of a polynomial function will tell us the behavior of a polynomial function around that particular zero. If the multiplicity is even, the polynomial function touches the x-axis. So for example, in this graph, the zeros of the function are 0 and 2, because these are the x-intercepts. However, if you look at 0, it just touches the x-axis, and notice that the y-coordinates here are negative, and here the y-coordinates are also negative. The sign did not change. So this is saying that this one has even multiplicity. Whereas if you consider 2 here, on the left of 2, the y-coordinates are negative. However, on the right of 2, if we follow the graph, the y-coordinates are already positive. The sign changes. And this means that the graph crosses the x-axis. That happens when the multiplicity is odd. We are now ready to sketch the graph of a polynomial function. First, we have to determine the end behavior. We did this from our last video lesson. Next, we need to find the x and y intercepts. And lastly, we need to determine the behavior of the graph at the x-axis.
Adi, Kuya, Nene, Tete. Please subscribe to my daddy's channel, Salamat.
So for example, let us analyze the graph of this polynomial function and graph this. For our first step, we need to determine the end behavior. The end behavior is determined by the leading term. What would be the leading term here? If you look at the factors, the leading term in this first factor is 2x, and the leading term on the second factor is x, but then it's raised to 2. So therefore, the leading term is 2x cubed. The exponent is odd with positive leading coefficient. So therefore, the end behavior is just like that of x cubed, which is down, up. Next is determine the x and y intercepts. For our y-intercept, we set x to 0. We get that y is equal to 9. For our x-intercepts, we set y to 0. Y is your p of x. We have 0 equals 2x plus 1, x minus 3 squared. Hence, we get that 0 is equal to 2x plus 1, or 0 is equal to x minus 3 squared. Solving for x, we get that x is negative 1/2, or x is equal to 3. For our last step, we need to determine the behavior around the x-intercepts. This one has multiplicity of 1. X equals 3 has multiplicity of 2. Odd multiplicity means cross, and even multiplicity means that it touches the x-axis. We are now ready to sketch the graph of our polynomial. We do this by first plotting our intercepts. From the y-intercept, our point is x0, y is 9. And from our x-intercepts, we have the points negative 1/2, 0, and 3, 0. This is the point 0, 9. This is the point negative 1/2, 0. And the point 3, 0. Next, we need our end behavior. Our end behavior is down, up. We go to the last x-intercept, so that's down. Then this one here is up. Next, the behavior on the x-intercepts. At x equals negative 1/2, we cross. So this means that cross, and we have to pass through the y-intercept, and then going back at x equals 3, touch. So meaning to say, it looks something like that. This is just a rough sketch of the graph of the polynomial. Here is the sketch of the graph using a computer. Next, let us graph this polynomial function. For our end behavior, we need to determine our leading term. For the factors, we have x squared. We just get the leading terms of the factors. Here I have x and x also. So therefore, that's x to the 4. This is even degree with positive leading coefficient. So therefore, it's up, up. Next would be our intercepts. For our y-intercept, we set x to 0. And we get that y is equal to 0 because we have x squared here. For our x-intercepts, set y to 0. Hence, we have 0 equals x squared times x minus 4, x plus 1. Setting each of the factors to 0, we get x equals 0, x equals 4, and x equals negative 1. I will already write the multiplicities here. This one has multiplicity 2, multiplicity 1, multiplicity 1, because we will need that for our step 3, behavior at the x-intercepts. This one has even multiplicity, so touch, and for the odd multiplicity, cross, cross. We are now ready to sketch the graph. First, let us start with our intercepts. From our intercepts, we get the points 0, 0. Here again, that's 0, 0, which is already here, and 4, 0, negative 1, 0. It's negative 1, 0, 0, 0, and 4, 0. For our end behavior, we have up, up. And for our behavior at x equals negative 1, it's cross. So it's cross, go to 0. At x equals 0, touch. So we have to go back. We do not know where until when. And then at x equals 4, you cross, which is correct. Cross. So here is a rough estimate of the sketch of this graph. So when we use the computer, we get this graph. Note that we will not be able to determine this point. You will need calculus for that, but at least we were able to get the shape of the graph. We obtained this. It's up, up, and then cross, touch, go somewhere down, we do not know where, and then cross again at x equals 4. For our third example, this is the same polynomial function that we had at the end of video lecture 25. We were able to get the x-intercepts and end behavior already. Our leading term is negative 4 x to the 4 with a negative leading coefficient, so therefore it's down, down. For our intercepts, the y-intercept were 0. For the x-intercept, we set x to 0 and we factor. Take note that if a polynomial is not in factored form, you have to factor it, because you will not be able to get the x-intercept without the factorization. Setting each of the factors to 0, we get x squared equals 0 or x squared equals 3/4. For this, we get x equals 0 with multiplicity 2. And of course, for each of this, we have multiplicity 1. I will no longer write multiplicity of 1. And lastly, we want to know if it's cross or touch. This one has multiplicity 2, so therefore it's touch. This one is cross. We are now ready to sketch the graph. We have 0, 0, square root of 3 over 2 and negative square root of 3 over 2. Probably somewhere here. For our end behavior, it's down, down. And then at x equals negative square root of 3 over 2, it's cross. Then at x equals 0, it's touch. There. We have to go back and something like that. Here is the actual graph. Again, we were not able to determine what these points are. You will need calculus for that. But the point is that we were able to get the shape of the graph.
Dito na nagtatapos ang ating lesson sa araw na ito. And this is once again Sir Absalon of MathAlas channel. And always remember, we are making mathematics more easy. Bye-bye!